So we've got a network out here that we can run programs on, and we don't really have to worry about backup of it since there's something like 11,000 of them or 10,000 nodes, and they all run the program, and we can pretty well be guaranteed that even if one of them fails, it doesn't make any difference to the network. So the question is, what can we do with this network? And I'm going to give you some examples. For instance, let's say that we have documents. So we've got some sort of a document, a design document for a piece of software. And we're a manufacturer. We have to comply with ISO9002 specification in terms of guaranteeing that everybody working on this project has the same current version of the document. Now, currently this stuff is being tracked on paper, but let's say we use a blockchain to track it instead. So we take the document and we produce the hash of the document. We have a contract out here that stores the hash in a table so that we can have maybe the hash and the title, okay, and the owner. So we can have all of those things stored out here in the blockchain. And every time we actually do a real update to this document, we go out and redo the hash. So we update the hash. So this copy that's out here is accurate. And every node has the same copy throughout. So instead of tracking this on paper, we guarantee that they all have information about the current copy. And on the document itself, okay, we put in a QR code that will lead us back to this document. So the QR code doesn't have the hash in it. It has the title owner information so that we can find the document and find the current version. Then what we do with the document itself is we go out to something like IPFS and we upload the document so that this hash that we're storing here is the name of the document inside the inside IPFS. So we've got a way to store the documents themselves combined with our accurate record of what the document is. And we now have a provable way of saying that this is a current and accurate list of what's going on with that document. So between the two, we now have a way to do what we've been doing on paper and has had people with literal 3-ring binder notebooks that they would go through and mark out and sign, that they are signing that this document is updated, that the transaction is current, that we've got a way of doing this digitally. So document storage. Accurate document storage. For people doing manufacturing systems, software, defense contractors, all the people that end up doing this standard, this is a huge thing. Because before this, all the documents had to be on paper. You had to have compliance officers going through auditing everybody's copy of the document, checking who had it, to make certain you're using a current copy. So the entire process can be automated with a blockchain. Now, what I'm going to do is we're going to look at a contract for something like this particular one. But we're also going to look at a bunch of other applications and say, these are the ways you can go about using a blockchain. And, we've got financial exchanges. Okay, that's good. But there are all these other things that they're good for. So this is one of them, is documents. So what are the properties of our blockchain out here that actually make this work? And I think there are 5 properties that are critical to getting these kind of systems to work, that you just can't get from any other kind of system. The one is proof of transfer. This is you going out and selling you bought a ticket to a concert, you're not going to use it, you go out and sell it. How do you guarantee that you've actually transferred the original from one person to another person? And blockchains excel at doing that. That's not really used in this kind of a system. Proof of date and time. This is critical to this system because When you have proof of date and time, you can guarantee that something is an original, that it is the most recent copy. Strong security. To be able to make this change here to this, you have to have strong security. Because you're creating a transaction, the transaction is a digitally signed component that you've got to be able to upload and call this contract. So you have actual real security and proof of that security. Proof of possession. And this is one of the things that you're exploiting in here. You're saying the owner of the document is really the owner of the document. They possess this document and they're saying this is the current thing. And the fifth one is uniqueness. And again, the ISO requiring the most recent, you're taking advantage of proof of uniqueness. Now, these are the things that I think, okay, there's one other that is also important in blockchains, and that is data distribution. But these are the things that a lot of applications are looking for. We have other ways of doing data distribution, like the F1 database and CockroachDB work really well for doing data distribution across networks. Okay, so there are other ways. But these are the things that are unique to a blockchain. This one is sometimes really useful. Okay? But I don't think that it's necessarily unique. We can get that one in another way. But those 6 items are what make blockchains useful. And if you're hitting, in this case, on 4 of them, then you're using a lot of the capabilities of a blockchain to be able to get this kind of an application to actually work and be successful. Now, you'll also notice that in this application, we've got some outside storage. Realistically, to make this application work, you probably have some sort of a login screen that the person logged in to the application, where we've got an upload button and a list of documents that they've got, dates and times. So there's a web application sitting outside of this that's tied to our back end. But our back end is built for us. We don't have to build that piece. IPFS exists. Do we want to have our own IPFS server? Probably, yeah. But all you have to do is install it. So this piece and this piece are built. And you could also use something like Amazon S3 or one of its competitors that's commercial, so you don't have to use IPFS. But either way, that stuff is all built, which means in terms of building the application itself, we've got some front-end pieces, we've got some upload pieces, and most of the work is done for us, including these pieces that are hard to get done and get done right. So that makes a useful application. Let's take a look at some other examples, and I'm going to come back to this list. It's in the notes, and I'm going to talk about different features of this list of useful things that allow this to become a successful and useful application.